Okay, let's talk about how you would actually calculate ANOVA, and I'll give you the formulas in this video, and then we'll actually go through an example in another video. Remember I said for an ANOVA you're looking at the F statistic, and specifically we're looking at the ratio of between groups variance over within groups variance for a single factor ANOVA. So between and within groups variance. And actually, just to change things up on you, we use a different notation for variance in ANOVA. We call them mean squares. So it's mean squares between over mean squares within, or you might see this written as mean square error. Just note that those are the same in this case for the single factor ANOVA. So mean square between over mean square within. And all this is variance between groups and variance within groups, just the way you're used to thinking about variance. Okay, and just to prove it to you, when we actually calculate the mean square, let's take a look at mean square between. When we calculate mean square between, we are using the sum of squares between groups over the degrees of freedom between groups. So we set this up exactly the same way we would calculate variance in a sample. And then for within, it's actually mean squares within, or error, sum of squares within divided by degrees of freedom within. Okay, so it looks like a lot, but it's really the same thing as variance, sum of squares over degrees of freedom. Here's the part that you have to remember. For degrees of freedom between, we're talking about the number of different groups that you have, which is k minus 1. Okay? And for degrees of freedom within, we're talking about the total number of people in our study minus the number of groups that we have. So that's big N minus k, total number of people, and you subtract out the number of groups that you have. So this k is the number of groups or levels of the independent variable. Okay? Okay, so just in case you couldn't read what I had before, this is everything. This is the F statistic, the ratio of the mean squares, just variances, and each mean square has its calculation, sum of squares over degrees of freedom, and really the only thing that you have to sort of commit to memory is this degrees of freedom between is the number of groups minus 1. But that makes sense, right? If you're looking at the degrees of freedom between groups, you just need to know how many groups you have, and then you subtract 1. And then we've got degrees of freedom within, which is big N minus k. It looks a little funny, but really all this is you're subtracting 1 from each of your individual groups and adding them all up together. So it's just an easier way to calculate that. So if you had, say, 5 people in 4 groups, then you would have degrees of freedom of 4 in one group, degrees of freedom in 4 in another group, and the third group and the fourth group, so it would be total of 16 degrees of freedom if you had 5 people in 4 groups. Or you could calculate it as 5 people in 4 groups is a total of 20 data points minus the 4 groups that you've got, so that's 16. Same thing. So it's not really that counterintuitive. Because the ANOVA involves sort of several components, it's nice to actually put it together in what's called a summary table. Here we've got a description of the source of variance between groups, within or error, and total. And here we've got our sum of squares, which you know how to calculate, right? You subtract the mean from each score, you square each one, and then you add it all up together. That's the sum of squares. So you've got sum of squares, and then you've got degrees of freedom between, within, and total, which is going to be the combination of these two, as well as the total number of people minus 1. And then we have mean square between and within, and then we have the F statistic. So you can actually commit those formulas to memory, or you can understand how this table is set up and work through this table. And that's one of the ways we actually know that you understand ANOVA, to present this kind of table with pieces of it missing so that you can see the relationships. So these two numbers are going to total, the sum of squares total. These two will total this. To get the mean square between, you're going to take your sum of squares and divide by the degrees of freedom going across the row here. And to get within, you're going to get your sum of squares within or sum of squares error and divide by degrees of freedom within or error, and you're going to get mean square within. And then to get finally the F statistic, we're going to take the ratio of those two numbers. So you can memorize all the formulas, or you could just understand how this table is set up and the relationships between them. I think this is actually an easier way to understand ANOVA. So those are all the formulas. Let's actually go through in the next video and use the data that I presented in the overview to find out if there are any significant differences among the treatment options on depression.